you had an opportunity. Yesterday, we talked a lot about saturation. Okay. Really quick, who can refresh my memory on what is saturation? What is saturation? I just need a hand. And if I don't call on you, feel free to also type it in the chat. Oh, I got Norman with a nice tall vert. Norman, unmute. Talk to me. What is saturation?
Raising my hand because
Say that one more time.
I said I was raising my hand because it said that the work wasn't found.
Oh, it said it wasn't found. Okay, great. We're gonna revisit that at the end of class. All right. Thank you for letting me know. Let me go ahead and get Harlem. Can you tell me what is saturation? Thank you, Norman.
Saturation is when a solute cannot dissolve into a solution anymore and it falls into the
Awesome. Thank you for that. All right. So now, yes, you already went over our big idea. When a solute cannot dissolve into a solution anymore, the solution is saturated. All right. And I would love to know what kind of dog you have, and we can talk about that later. So now, who can best explain my chocolate milk? Who can best explain what's going on with my chocolate milk? Let me go ahead and get a hand. Who can best explain what's happening with our chocolate milk? Go ahead, Graylin, and feel free to still respond in the chat to still get those points for today. All right, go ahead, Graylin.
So what's happening to your chocolate milk that it's fully saturated, so all those particles that you put in the chocolate milk, they sink to the bottom because there's no more room or space.
Yes, right. So there's no more room and there's no more space, right, to dissolve our solid. All sunk to the bottom. Beautiful job. Shout out to Harlem. And then he threw the alley-oop to Graylin to go ahead and finish that. So now I have a question in the chat. Do all substances saturate at the same concentration? Do all substances saturate at the same concentration? I'm taking predictions. So go ahead and type in the chat yes or no. Do all substances saturate at the same concentration? Type in the chat yes or no. I have one person who said no. Since the same person who said no, Ajaya said no. Okay. No, because some take up less space. No, Amira saying no. Who can make a prediction? Why do you say no? I just want to know, why do you think no? All right, let's go. Amir Robinson. Amir, why do you think all substances do not saturate at the same concentration? What you think? Amir Robinson going once. Got you. So let's go ahead and try Deshaun. Deshaun, can you talk to us? Why do you think all substances do not saturate at the same concentration? I love the explanation you use in our message, so you can just go ahead and use that as well.
Okay, I say no because I think some solutes take up less space.
Some solutes take up less space. Okay, so that means that you also think some solutes take up more space. Interesting. All right. So we're going to do an experiment. We're going to find out if all substances saturate at the same concentration. Okay. So in a second, we're about to go back into our little game, our little activity that we're working on Thursday. All right. And we're going to play around with it a little bit. As we're playing around with it a little bit, you're going to get a chance to do some independent work. But first, let's go ahead and do this together. So in a second, Norman, I see why I said that. I'm gonna send it back to you in the chat, and so that you have another opportunity to complete that. Thank you for letting me know, Norman. Because you thought I forgot about you, but I could never. All right, I'm gonna go ahead and send this straight to your computer. So as soon as you get there, go ahead and open it up. And once you open it up, it should be a PowerPoint slide, and it should look a little something like. Let me let you know what it should look like. New Kirk, go ahead and try the link I just sent now. It should work. The one before didn't work, and I know why. Awesome. Braylon said he's there. All right. And when you pull it up, it should look a little something like this. It should say boss science words. All right. It should revisit the same thing we went on yesterday. But you're going to skip to slide number 3. Once you get to slide number 3, put 3 in the chat so I know that you are on the correct slide. Good. I got 333 strayways. I got, what else I got? Got you. A lot of people on slide number 3. Okay, perfect. Now, I'm going to split my screen because I know that you already know how to split your screen, so I might be going to show you again, but we already know how to split our screen. So I'm going to go ahead and split my screen, okay? So on one side, I'm going to have my my slides, and on the other side, I'm going to have my experiment. Or my interactive assignment. All right. So I kind of already did the first one, but you're going to see how I came up with that. All right. So I have my first substance or my first solute. All right. Now, my job is I want to figure out what is the maximum concentration for this solute. Notice, all right, I already have my concentration meter. I measured my, it's in my water or my soon to be solution. All right. And I'm going to drop my drink mix. And I'm going to keep dropping it. And my goal is to see at what point it becomes, when it reaches maximum concentration. Or another way of saying that is when it starts to saturate. Boom. Okay. So now I know that my drink mix maximum concentration is 5.96. Okay. Now, quick question. I just want somebody to refresh my memory. If I add more drink mix, will my concentration increase, decrease, or stay the same? If I add more drink mix, will my concentration increase, decrease, or stay the same? Be ready to tell me why. Y'all know I love why. Be ready to tell me why. Will it increase, decrease, or stay the same? Be ready to tell me why. Okay, I got Sincere. He has an opinion. Raylan has an opinion. I'm looking to see who else has an opinion. Who else is willing to just try and step out there? Good. Okay, Amira said it would increase. Graylin said it will stay the same. Okay, good. I'm looking for a few more responses in the chat. Oh, okay. Graylin coming with the reasoning. All right, he has a reason. Let's see. I'm looking for a few more responses in the chat. We got in here? Ariana Robinson. We got Azari Bell, Lante, Ajaya, Cecil, Dakota, Ebony Bennett, Harlem, Kalani Mack. I'm looking for more responses. Norman, what do you think? Do you think it will increase, decrease, or stay the same? Norman, do you think the concentration will increase, decrease, or stay the same?
I think it would decrease.
Okay, great. So now I'm about to, Norman, you still with me?
Yeah.
Good. I'm about to add more drink mix. Let's see what happens to our concentration meter. Okay? What do you notice about our concentration meter, Norman?
It goes back to the same color.
We're looking at this number right here. Do you see this number I'm looking at?
Yeah.
Great. What does that number say, Norman?
9.
Don't forget the decimals, 5.9, but go ahead.
5.960.
Good. Now, does that number increase, decrease, or stay the same?
Stay the same.
Good. Now I want to know who can tell me why that number stays the same. Why does that number stay the same? I love your Batman shirt, and I love that you try to participate today. Why does that number stay the same? Let's go, Graylin. Why does that number stay the same?
The number stays the same because it's saturated, and if it's saturated, there's gonna be no more space.
There's no more space. Let me ask somebody else. Sanaa, why does that number stay the same? 5, 4, 3, 2. Great. Ziana Jones, why does that number stay the same?
Because there's no more space.
Good. Norman, why does that number stay the same?
Because it is saturated.
And there's no more?
And there's no more drink mix.
What did you say, Ziana? There's no more what?
Space.
There's no more space. Norman, so why does it stay the same?
Because there's no more space.
There's no more space. There's no more space for our solute to dissolve, okay? So now I just wrote my maximum concentration here, all right? Now I'm going to do the next one. The next one says cobalt. Cobalt's nitrate, all right? So I have the same, yes, it's reached its limit. I have the same concentration as measure my water, and I'm going to drop. All right. And I'm going to keep going. And I'm going to keep going. Ooh, taking long. Boom. Great. What number should I write on my PowerPoint for where it says cobalt nitrate? What number should I write on my PowerPoint? Good. Is that it? There's an 8 there? Oh, you got to look close. Oh, okay. I was wondering, I was scared. All right, yes, Sincere, I'm going to write 5.64, okay? Now you're going to get a chance to do this on your own. I'm dropping the link in the chat, and your job is to fill out the rest of the substances at their maximum concentration level. I'm going to give us about 10 minutes to complete this independent work. After you've completed the independent work, you're then going to go to slide number 5. Once you go to slide number 5, you're going to drag and drop the green check. Actually, no, I'm gonna revisit, and then we're going to talk about slide number 5. So go ahead and complete slide number 3. Once you've completed slide number 3, then you're going to say done. So I know that we're ready to move on to the next activity. Okay, so 10 minutes is on the clock. Go ahead and get started. Oh wow! I saw Norman sit up in his. I saw Norman sit up. He ready to get started, and he got his Batman shirt on. He is unstoppable. All right. Great. I'm starting with, actually, I always start with Azari. So this time I'm starting with Desiree. All right. So Desiree, you're going to go ahead and get started with slide number 3. The first one's already filled out. Go ahead and let us know what is the second substance. Got you.